Does anyone remember how to do that? Let's start off with probably the newest and weirdest piece of information you got yesterday, is what I would assume. So if I give us two fractions, what is a guaranteed way to find the fraction between those two? I mean, you could. Now listen, I could find an LCD, right? So I mean a quick way to do it. Yeah. Add what together? Yeah, the numerators and denominators. So I haven't proven this to you yet, but if I do this, I will always end up with Jeff. I won't end up with Jeff. I'll always end up with a fraction that's in between the two fractions I got. Now on the surface, I need you, and I really warned you about this, because you show this to a student and it's going to reinforce their misunderstanding about fractions. To add two fractions, no, the problem didn't say add these two fractions. It said find a fraction that's between these two. That is a method I can use. Yes? That is the one place that makes any sense. Okay. In fact, maybe it don't make sense, and I don't blame you if it doesn't. I'm going to leave it up to you guys. Do you want to see part of the proof of this? All right, the only thing I saw was a no. It's fine. So you guys just take this on faith. I love it. You're like, yeah, you seem like a trustworthy guy, Jeff. Why would they hire you if you weren't trustworthy? Okay, so that's just a thing you can know. Yes? I'll be all right. What else did we talk about yesterday? We talked a little bit about more basic stuff. We talked about how to represent fractions. Yes? Using like a set method, kind of like, breaking something up. And this led into, so what would this represent, of course? Now, the trouble comes, what if I had something like this? And a student said, well, that's 1, 2, 3, 4, 5. 1/5. That's 1/5, Jeff. Is that good? No. And what's going on in that example? Now, you can see how a student, you show them a bunch of examples like the first one, they could very easily misinterpret the second. What's wrong with the second? Why is that not 1/5?
It's not equal.
Yeah, all the things I've cut it into aren't equal. So it doesn't make sense to say that's 1 out of 5 cuts, because they have to be all the same size for that to make sense. So how do I adjust that? Yeah, if I just cut the other 3 pieces in half themselves, then I can see what that really is. Chop, chop, chop. Now, real quick, that was half of this, yes? Does anyone know what 1/2 of 1/4 is? 1/8. And sure enough, that's 1, 2, 3, 4, 5, 6, 7, 8, 1/8. Yes? Kick ass. You guys kind of with me? We haven't officially made it to multiplication of fractions, but you guys should know. If you think about it, division by fractions, we're going to talk about how to do that visually. That's going to be trippy. Okay, let me think. What else? I didn't really prepare a review because I wasn't thinking about that. But we talked about like the basics of adding some fractions, I believe. Did we? Maybe not yet. No. We talked about reducing fractions. Yes? What's one thing that would help me figure out how to reduce something like this? What you got, Jeff? I don't know, Jeff. 135 over 396. Ooh, that's gross. What if I said I want you to reduce this? What if I went further and said you can't use a calculator? We'd all say, screw you, Jeff. You don't have. Does anyone remember, we actually did a problem like this just so I could illustrate a previous thing we learned not too long ago helps us in problems like this. Does anyone know what that might be? I mean, what are you trying to do when you're trying to reduce? You trying to find numbers that In what way? You're trying to find numbers that do what with those two numbers? that go into them, yes? Numbers that are divisors of those two. Do we have rules that tell us when certain things, all right? So obviously 5 doesn't go into both, yes? Because the bottom screwed that up. Good job, bottom. Obviously 2 doesn't go into both because the top screwed that one up. Good job, top. What else can I check? Does 4 go in? No, 4 doesn't go into 35. It goes into 96, so the top screwed that one up. Well, you did, Jeff. You made this promise. That's very good. So what else can I try? What's another rule we can try? All right, we can try the rule for 3. What's the rule for 3? Yeah, so what do I get? 1 plus 3 plus 5 is 9. 3 plus 9 plus 6 is? So what? So does 3 go in? What bigger goes in? Because they're both multiples of 9. Why does 6 not go into both? Because the top's not even. Let me stop for a minute. What I really need you guys to understand, and what you need to reinforce in your classes is when we learn an idea in a section and we leave that section, that does not mean the idea is staying there. Right? The divisibility rules thing is stupid useful everywhere. Okay. So how would I do this? I would divide by 9. And what would you get? You could do 9 and 135. 1, 9 minus 45. 5, 15. Over. 9 goes into 39 how many times? You could do it, you could do it, you could do it, you could do it, you could do it. 4 times, yes? And then that would be 36 minus equals 36. 4. Does that reduce any more, do you think? That one's really easy to see because 15 only has what factors besides 1? 3 and 5. And 44 doesn't have 3. So I'm done. Okay, kick ass, yes? Yes?
Where'd you get the 9?
Oh, that's the whole thing we talked about just a second ago. 1 plus 3 plus 5 is 9. 3 plus 9 plus 6 is 18. So therefore 9 goes into both. So that's the thing I'm going to divide by. Now there could be something else afterwards that I didn't notice that goes in, but we see, I'm done. Alright, so this is stuff we all know. I know you guys, most of you maybe. Does anyone actually not hate fractions that much? Just out of curiosity. You're okay with fractions? Yeah. Thank you so much. But just to let everyone else know, it's a common thread. I don't care how high of a math course I teach. I always have people that are bad with fractions. And then a little piece of me cries. Sometimes me, I cry. I understand why fractions are weird, because you don't really use them that much. You really don't run into them that much. Okay. Oh, I think it's enough for now. Yeah, so let's do this. So I'm gonna pass these out. Let me see. Did anyone else come in? 2, 4, 6, 8, 10, 12, 14, 16. I lost somebody. Wait. 2, 4, 6, 8, 10, 12, 14. I had 17. What just happened? I'm in. 2, 4, 6, 8, 10, 12, 14, 17. I think I was lining people up here. Okay. So I'll watch a math teacher try to remember how to teach. So let me see. 6, 17. I'm going to do groups of. Yeah, that'll work. Yeah. So I've got ghosts. Where are my ghosts at? Move with me now. So let's see, where do you guys go? Okay, my ghosts, maybe go right there. There's like 4 chairs. You can turn those around. Those 2 people are like, yeah. Ghosts here. Where am I? Oh, did I not give you one? Oh, come on, dude. Here, you can be a room. All right, then I got spiders. Where are my spiders? Spiders, spiders. Why don't you guys come like right here? Right there. Like turn those chairs around. Yeah. Then I've got brooms. Why don't the brooms go right over here? Right, reverse chivalry is alive. Go over there. Pumpkins? Where are my pumpkins at? Oh, there's more than one pumpkin. Ah, there we go. Okay, I'm sorry. Still didn't see you guys. Why don't you guys come over here? I've displaced everybody else from this area, so you guys can go over here. All my pumpkins over that way. Cats. Where are my kitty cats? Alright, so kitty cats, go back there. Yes, everybody, right? Okay. So go ahead and start with me. When you get to the part where you have to use manipulatives, come on up here and grab them. Some of you guys,